GhanaSongs.org.
My level up. My level up.
Hi, my friends, my colleagues, my teachers, my students. You are welcome to the Science Ambassador series on the Smart Way lectures. This video will be treating a main chapter on chemical bonding. We are going to take our time to really delve deep into the concept of chemical bonding. Not to wait too much time, what exactly is chemical bonding? What exactly is chemical bonding, my friends? Now, before even I define chemical bonding, now let's consider some few things that happens around us. Now, this is the question I want to ask. When you put water on fire and you want to boil it, why does it take a very long time for us to boil the water, for the liquid water to be converted into the gas water? Why does it take a very long time for the water to evaporate or to begin to form bubbles on the surface? You will realize that you have to take a lot of energy. You will have to heat the water for a very long time before the water begin to boil or turn into a vapor. Now, why is this happening? Now, when you hold a piece of chalk in your hand, why is it very difficult sometimes for us to break that piece of chalk? What is actually happening inside them? What is happening inside the liquid and what liquid water, and what is happening inside the solid chalk? What is actually happening? Now, in our first lecture, when we were talking about the particulate nature of matter, we realized that matter is not a single continuum. It's not a single continuum, but made up of separate entities that comes together to form them. These separate entities, these separate entities are what comes together to form the solid or to form the liquid. For instance, when you take the water is made up of elementary building blocks, and the building blocks of water is basically the H2O molecules or molecules. The atoms that are made up of these molecules are hydrogen and oxygen. Now, so when you are boiling this water, you are supplying the heat of the water, you realize that you are trying to lose or break down a certain force of attraction that exists between, or that is holding these molecules and these atoms together. And so the boiling takes very, very long time before it happens. And so, and the chalk too as well. The chalk too, which we chemically know to be CO3, that is CaCO3, are made up of several group of atoms. The CO3, there's the calcium, the carbon, and then the oxygen. Several group of these molecules come together to form the solid chalk. And so it is very difficult for us to break them, because the particles or the atoms or the molecules of this chalk are held very compact and very tight together. And so it requires a little kind of energy for us to break down this chalk. Now, these are all happening because there is a force of attraction that is holding the entities or the individual particles that consist of them. This is happening because there is a force of attraction that is holding the molecules and the atoms that are in these substances. And so it requires a lot of energy to break down them. And so when we say chemical bonding is what make a substance to be exist in a solid form. It is what makes a substance to exist in a liquid form. It is also what makes a substance to exist in a what? In a gaseous form. Particles are held together. Particles are held together. They are held together by a certain force of attraction. Now, this force of attraction is what we call chemical bonding. And so when we say chemical bonding is the force of attraction that exists between the particles of matter. Again, a chemical bonding is a force of attraction that exists between the particles of matter. Specifically, it is a force of attraction that exists between the atoms, the molecules, and the ions of matter. It is a force of attraction that exists between the atoms, the molecules, and the ions of matter. And so that is what we call chemical bonding. And then we are going to delve deep into this. Now again, why do atoms bond to each other? Why do molecules bond to each other? Now let's carefully take a typical example. Why do atoms bond together? Now when you carefully study the various atoms that we have, you would realize that certain atoms do not have a complete electronic configuration. For example, you realize that hydrogen has only one electron in the first shell. Helium has 2 electrons in the second shell, which is stable. Lithium has only 1 electron in the last shell. The electronic configuration of lithium is 2 and 1. And so before these atoms can bond to each other, they must have a stable state electronic configuration. And so what happens? These atoms either lose their incomplete outer shell or take some electrons to make them complete. In the process of losing and the process of taking, they chemically bond with the atoms that are close to them. And so the essence of chemical bonding is to bring stability of a compound, is to bring stability of an atom, is to bring stability of ions, and to bring stability of the whole substance that we see. Without chemical bonding, there is no stability. And so substances should be stable. We should be able to use substances around us with ease. And so because we use them with ease, it means that whatever is made up or whatever they are made up of them, okay, are also stable. And so the atoms that are in all substances, also would want to be stable, just as things around us always want to be stable. Because without their stability, we cannot use them. We cannot use them. We hold a piece of chalk because the chalk we have held is a stable substance. And so the atoms that are there are also a stable substance. But this stability was caused as a result of chemical bonding. The atom would either lose electrons if the electrons on the outer shell is not up to 8 or is less than 4 or 5. It will lose the electrons. For example, the group 1 metals and the group 2 metals and the group 3 metals, which have 1 electron, 2 electron, and 3 electron respectively on the outermost shell, loses them to other atoms that needs them. In the process of losing them and other atoms accepting them, they form what we call a chemical bond between them. So the essence of chemical bonding is to bring stability within the atoms, or to make the atoms very, very stable. Before we end this lecture, let's quickly look at the 2 types of chemical bond we have. There are 2 types of chemical bond. The first bond is the interatomic bond, and then the second bond is the intermolecular bond. Now, the word inter simply means between. And so when we say interatomic, we simply mean the bond that exists between the atoms of a substance. The bond that exists between the atoms of a substance. And when we talk about intermolecular, we are also talking about the bond that exists between the molecules of a substance. The bond that exists between the molecules of a substance. Now, let me take this for example. When you are heating water or you are boiling water and the water is separating or is boiling or is turning into vapor, what kind of bond are you overcoming between the entities? What kind of bond are you overcoming? Are you breaking the interatomic bond or you are breaking the intermolecular bond? Again, when I hold a piece of chalk and I break it, now am I breaking or am I overcoming the interatomic bond of the chalk or the intermolecular bond of the chalk? Or when I take a piece of paper which is made up of several cellulose molecules coming together, when I tear this paper, am I breaking the interatomic bond of the paper or the intermolecular bond of the paper? Now, all this, you can simply understand them because interatomic bonds are not physically broken. Interatomic bonds are not physically broken. We don't just hold the paper and we tear the paper for us to break down the actual bond that hold the atoms within the paper. What we are doing is that we are breaking the intermolecular bond. So when I take the paper and I tear the paper, what I'm trying to do is that I'm trying to separate or I'm trying to break down the molecules of the paper, that is the cellulose molecules of the paper. I'm saying that the paper is made up of several molecules, otherwise cellulose molecules that come together to form the paper. And so when I tear the paper, I'm not actually breaking down the real bond that is happening between the individual atoms of the paper, but rather I'm breaking down the force of attraction that is holding the separate molecules, in other words, the cellulose molecules of the paper. For example, let's also take the boiling of the water. When we are boiling water, what actually are we doing? We are not actually tearing the hydrogen away from the oxygen, but rather we are separating the individual, or we are separating the molecule, one molecule of H2O from another molecule of H2O from another molecule of H2O. What we are doing is we are separating the separate molecules of the water. And so the intermolecular bond can easily be overcome by physical separation, by tearing, by hammering, by a lot of simple things that we can do around them that can break down the molecules apart. Remember that the molecules are bigger than atoms, and so that the bond that exists between molecules are weaker than the bond that exists between atoms. And so interatomic bonds are very difficult to overcome. We don't easily take the paper and we break it to tear the carbon, the hydrogen, and the oxygen apart, because they are the actual atoms. They are the atoms that are found within the paper, and they are held by a very strong force of attraction. And this strong force of attraction is what we call the interatomic bond. Now, it is very difficult to separate the individual atoms that are in substances, like in the paper, like in the water, and even in the chalk. What are we doing when we hold a piece of chalk and we break down when we break the piece of chalk? What are we doing? We are not breaking the calcium away from the carbon. We are not breaking the carbon away from the oxygen. We are not breaking those things. When we break down the chalk, what are we doing? We are breaking the Ca, the CO3, the Ca, the CO3. We are breaking the Ca and CO3 apart. We are breaking the Ca and the CO3 apart. We are breaking the Ca and the CO3 apart. We are breaking the separate molecules that are there. And so interatomic bond is a bond, it's a strong bond that exists between the atoms of substances. Again, the interatomic bond is a bond that exists between the atoms of what? Of substances. And here the intermolecular bond are bond that exist between the molecules of substances, and generally they are weaker. That is why we can tear the paper. That's why we can hammer metals and easily break them apart. That's why we can tear a sheet of paper. That's why we can boil water. All this because we are separating the individual molecules that are in the paper, but we are not actually cutting or breaking down the actual bond that hold the atoms together. So interatomic bonds are stronger than intermolecular bond. Now interatomic bonds are only broken through what we call chemical reactions, when electrons are being transferred. That is, they are being broken by chemical reactions. When electrons are involved in the reaction, that is when the interatomic bonds are being broken down. Thank you.